We often talk about seasons, and the question really comes down to what are different seasons. We know that they appear to be times when certain characteristics occur, but let's look and see how these really happen from a biological point of view. Everything goes back to the sun because we're looking at photosynthesis and we know that sunlight comes down on planet Earth, and as sunlight comes down on planet Earth, it warms everything and it causes the wind and it causes rain and it does all sorts of interesting things to plants. What happens here is the Earth is tilted on its axis. It's about 23.5 degrees on its axis, which means as it rotates around the sun in various places, you get a different lineup of material. We have three lines in here. The bottom line is the Tropic of Capricorn. The upper line is the Tropic of Cancer. The center line is the equator. This shows what we call the winter solstice. And in the winter solstice, the axis of the Earth is tilted away from the sun. So you can see the sun's rays are coming in and they're really orienting themselves more towards the southern hemisphere. The direct rays are right over the Tropic of Capricorn. During the progression towards spring, this is what we call the equinox. And in this particular case, what happens is the axis of the Earth is oriented vertically, which means the sun rays come over the equator. If we look at this axis, what we see is the north-south axis of the Earth is pointed in the direction of the sun, which means the direct rays are over the Tropic of Cancer. This is what we call the summer solstice in the northern hemisphere. This would be the winter solstice in the southern hemisphere because the sun rays are directly over the Tropic of Cancer. When we have this occurring, days tend to be longer, the temperatures tend to be higher, and you tend to have more weather activity in it. And then as the Earth spins around the sun, eventually it returns to the equinox, and this is the autumnal equinox, and in this case what we get is we get the progression of the sun down towards the equator as it is on its journey south because the axis of the Earth is changing in relation to the sun. What this means is that as we look at the seasons, we get differences in daylight length, we get difference in daylight intensity, and that changes weather forecast for us during that particular time. Here we've got 4 photographs. These are all taken of the same area, and this one starts out in wintertime. And what you see in wintertime, now this is wintertime in North Florida, which means that we've got things that are green all year round, like pine trees, and there's one in the foreground, and there's some oak trees in the background, and they are green all year round, but they do lose leaves. But during the wintertime, deciduous plants drop their leaves. This is because there's not enough photosynthetic activity. It gives the plant a chance to recycle its leaves, which allow the leaves to fall on the ground, which will allow for recycling of nutrients. And it will also give the plant a chance to regroup itself, so to speak, for the spring. As you see this, you can see that these trees, and these are Bradford pear trees, have lost their leaves, and a lot of plants have lost their leaves, and the area looks much less green. Now, in northern Florida, we don't get snow, so there's no snow cover on the ground. If this had been up in a northern climate, the grass would have turned brown because you would have gotten a lot of frost on it, and you may have snow covering. This next picture shows springtime. These trees are now white, and they are white because they are flowering, and normally during springtime we get this flowering occurring, and as we get this flowering occurring, it is due to the fact that the daylight is increasing, the temperatures are increasing, and this is time for these plants to come out and reproduce, and as they reproduce, they're going to have a chance to produce the seeds and everything for the following year. Here, this is summertime. During summertime, the fruits are filling, but what we've got is we've got a lot of leaf area, and as we've got a lot of leaf area, the plant is able to regroup itself, generate new energy to fill up the fruits, to produce the seeds, to be able to grow, to increase in size, and get ready for the following year. We have a lot of development of buds, we have a lot of development of leaves. And again, during this time, the summer is more direct, daylight is longer, you have longer days in here, and so it's a much more productive time for plant growth. And then here, this is autumn. Daylights are starting to get shorter, temperatures are starting to drop. The change in the spectral colors as this occurs triggers the plants to go into its autumn type mode, and what we get is we get this color change in there, and as we get the color change, this is in preparation for the leaves to drop off, and what's happening is the chlorophyll is no longer functional and the accessory pigments that are in there start showing up, and we get these absolutely gorgeous type areas. And then as time progresses, we'll go into winter where the leaves have dropped off, and then we start this clock over again. So every year we have this seasonal progression where we start out and end back up at the same spot. All of it is due to positioning of the Earth's axis relative to the sun. So when we talk about seasons, we are talking about things that are relative to the Earth's position. Now, depending on where you go in the world, if you live on the equator, you don't necessarily see seasons like this because winter, spring, and fall could be compacted into a very short period of time because you don't get a lot of variation from one time to the next. In a place like that, you might get seasonal difference in the amount of rainfall you get, but it's not necessarily a tremendous variation as far as color goes. So seasons become very important for the way we look at what is occurring relative to plant growth.